Good afternoon. One of the thing over here. I'm Dr. Amana Singh, and I'm going to present this particular topic called instruction execution cycle and sketching sequence. Students, this particular topic, I hope it is very useful for those students who are willing to pursue this particular content for preparing the content in terms of your execution cycle, in terms of executions. And if they are keenly interested to know that how this particular instruction is supposed to be get faced during the execution period. So let me allow to go for this particular sort of thing. So now I'm start my presentations over here. So whenever we say supposed to go for this introduction of this particular execution cycle, so first and most important thing which must be realized over there, like how do we able to proceed? So normally what happens like here, I'm just going to let you explain the things like how this particular, execution cycle is supposed to be understood. So first of all, we will start with the introduction, followed with the fundamental concept that is required as a pre-cap fundamental concepts. Next to this, I will also going to let you teach about this pages of the instruction cycle, followed with the timing diagram, where actually we are used to perform your read and write operation on the particular memory. Then we'll discuss about this IO read and IO write operation. And then after we'll discuss that how the combinedly they are going to be able to work together to accomplish the things in a very precise way. And finally, we will go for the conclusion. So coming to the first and most important thing, if I'm supposed to say, so what is the instruction? Normally, whenever we're supposed to go for analyzing or understanding about this particular content, we are trying to know what exactly the instruction is. So when you're supposed to go for understanding the instruction one, so instruction is nothing but usually it is a kind of machine language, which is usually consists of certain things called as your operational code. Because without the operation, which you cannot able to understand that what exactly you want to perform. Or if I supposed to say, system cannot understand what to do. So a operation code has to be there. And with respect to this operation code, the next is the particular address field where actually you are going to understand how this particular, the memory addresses are going to be take part in terms of the identity of your values, which is supposed to be get operated by the help of your operand code. And the most important thing that I am likely to explain you over here by using an example, say suppose we are going to perform, say suppose addition of two numbers, right? So here, if I supposed to go for performing the addition of two numbers, then definitely here I am taking this add x and y as a two content over there. And in this particular case, what exactly my main intention is that I'm going to add the content over the memory location x and y, right? So when I'm supposed to go for performing the addition operation, then where does the exact result is going to be get stored? So naturally, the content is going to be get stored in the location of your y, as we all know it. So now, in this particular regard, say suppose if I'm going to add, and where actually my x value is 99 and y value is suppose 100, right? So if I'm supposed to do, then in the operational code, the things is going to be get represented in this particular manner. The diagram is being stored over there in activity. Like the operational code has to be of your 8 bit, as you all know, and the address bit is of your 16 bit, and the another address too is also of your 16 bit, right? So in your machine, this particular thing is going to get represented in this particular manner, which I have just displayed in terms of the diagram, right? And I hope all of you are bit sure about this particular thing. Yes, of course, now I'm taking part to the next particular thing, which is more helpful in terms of understanding the recap things, right? So here we will refer this particular term as a fundamental concept. So where actually the fundamental concept, I'm likely to discuss some of the important things, like what execution is supposed to be get done or which one is supposed to be get solely responsible for executing the things. So here the first and most important thing is the processor, which usually we call it as a CPU. So this is a particular major component in our computer, which is an active part, okay, being considered during this particular computer system. And it does overall everything over there, like data manipulation, decision making, any sort of calculation, what we supposed to do. So everything is going to be get done by means of this processor itself, right? Now, coming to the next important part, yes, of course, the data path. Here, in terms of the data path, we mean as you this one as a data line also, which is nothing but a combination of a particular paths which will let us establish the processor and its hardware over the scenario. And this is only solely responsible to perform all the operations which is required by the computer over there. Right? For example, suppose if you are going to go for calculating some sort of values, or you are going to perform any arithmetic or logical operation or anything, whatever you want to perform. So no doubt the processor will do the task, but the data path is used to establish the mean, you can say the communication in between of these two particular sort of things. And based on this only, the entire thing is going to be get accomplished, right? And the third and most important part is the control unit, right? So control in the sense like when the processor is supposed to go for operating the task, or say suppose it takes some resources uses over there, then the hardware are going to get utilized on the basis of the control signal itself. So who is going to generate this control signal? So here the control signal is being generated by the control unit, recognizing which the other resources are going to respond. So in short, if I suppose to say like which one is called as the brain of the computer, so normally we are going to say that yes, the CPU is the brain of the computer. So in that sense, if I suppose to say, so the control unit is nothing but it like a nerve system which is supposed to supply all the signals to the resources and recognizing which the resources are coming into the action. Right? So if the control signal is get failed, the entire system is supposed to be get collapsed over there. Right? I hope this particular part is a bit clear to everyone. So moving to the next, as per our content, what we have discussed, like I'm just going to discuss the most important crucial thing over here, like what are the pages are there in terms of the instruction cycle. Normally, what happens to it is like whenever we're supposed to say about the instruction cycle, it is used to have some pages, right? Normally, I'm just going to discuss this particular parts. Like here you see this is a particular diagram is there, which is supposed to go for defining the instruction page. For the first page is called as your paging. The second one is called as your decode, where actually the conversion technique is supposed to be get took place. Then you are going to have the operand page. Just now, before of this particular thing, we have already seen that yes, in an instruction, the operand is a very much important thing. Without this operand, the things is going to be able to compute it. Next to the operand, you are going to have the execute, then result store, and further, you are going to have the next instruction, which is again has to go through all the particular stages. So as per now, if I supposed to say how many stages do you have, if I supposed to say how many stages do you have, then you can say that yes, there are 5 stages are there. Starting from the fetching, then instruction page, then instruction decode, then operand page, then you are going to have execute instruction, and finally result store or write back. The same cycle is going to be again repeated for the each and every instruction which is supposed to be get, sent for the execution tool over there. So now if I supposed to say in terms of your execution of the particular instruction, how this particular thing is going to be get done. So no doubt here there are some other registers are also there, which is going to be get worked in the background part. Okay. And without of which it is very difficult for a system to get it analyzed. Right? So if I suppose to say what exactly the instruction page is just able to reveal. So here you see the instruction. When you're supposed to say about the instruction execution, then the fetching, decode, and execute. These are the 3 most crucial things are there, which is you can say that yes, that is a very important concern, right? So when you're supposed to go for fetch operation, the fetch is nothing but fetching the data from the corresponding resources. So if I supposed to say, who will let us inform about this particular thing? So there is a term called as a PC, which is a program counter that is a register, which is used to hold the address of the next instruction that takes part in the execution process, right? Now the question arises, in terms of your PC scenario, how the PC will going to be get updated over there? So there is another register is also there in the control unit, which is called as an instruction register, which is used to take the address of the current ongoing instruction, right? So if I suppose to say this IR is supposed to hold the current instruction over there, the address of the current instruction over there, then based on the value of your IR, the PC is always going to be get updated, right? Then the next term comes decode. So decode means what? Of course, here you are going to break down the particular instruction into the small mnemonic form. And those particular mnemonic forms are supposed to be get sent to the execution tool over there in order to get it executed. And execute, of course, that is a runtime environment where actually the instructions are going to be get processed. And then after we come across the variable outcome over there, right? So this is a very just scenario over there. Like these are the pages are there. So definitely you could expect more questions from this particular part also that yes, what are the pages are there. So at that time, you need to let it elaborate all these lot of things in a very detailed order, right? Coming to my next slide. Yes. So here actually I'm continuing the same part over here where actually I'm trying to let you explain about more about the fetch operation. So as I just told students, like whenever you're supposed to go for the fetch operation, the fetch means what? The next instruction has to be given over there. So fetch next instruction into IR. So if I supposed to say in terms of your IR, so IR is always going to hold the current address of the instruction which is there in the execution process, right? That we have already discussed. So here I've taken one example. Let's say suppose if I'm going to consider like I'm having a instruction where the word size of your 4 byte. Then every instruction stored in a word and that is a memory byte is addressable over there by means of this particular register, right? And followed with this, if I suppose to consider this PC, so the PC will be get updated in terms of your IR value, and each value is going to be get added over there, so that the PC will be get updated accordingly. For example, here I have chosen the value as 4 byte. So naturally, I am writing over here PC is equals to PC plus 4. Say suppose if it is of your 1 byte, then what value will be write? PC is equals to PC plus 1. Similarly, if your word size will be around 3 byte, then how much you will write? Like PC is equals to PC plus 3. So according to this, the particular next instruction is supposed to be placed over there, right? So if I supposed to say over here, now which one is the most important concern over here? So that most important concern is nothing but the word size that we supposed to take it over there. Okay. So looking into the particular size, accordingly the values are going to be taken with the accountability and the values are going to be considered. Right? I hope this part is clear over here. Now moving to the next, I'm going to discuss about the timing diagram. Right? So whenever we say suppose about this timing diagram, then the most important concern is like how this timing diagram is going to be accomplished over there, right? So whenever we say suppose about the timing diagram, the first thing comes is a memory read operation, right? So whenever you say supposed to have the memory read operation, the memory read operation means what you are performing some operation on the memory. And this is always, a person, as you can see the operation where actually you are not going to make any changes over there. Means it is a non-destructible operation where you can perform anything which is supposed to be read multiple times, right? If I supposed to say, so here you see, we are supposed to have this memory read operation. The first thing I'm taking over here is your address is placing at the beginning of the clock, right? Every CPU is supposed to be able to perform this particular operation from the basis of your clock cycle, right? During this particular clock cycle, I'm just explaining in terms of the example, like after one clock, okay, the CPU is always going to assert the read operation over there, and it causes the memory to place the data over the data bus. And according to this, all the particular other processes are going to get synchronized in the overall scenario. For example, you see here, I'm just going to have a sequence like this is my clock cycle that you can see over here. Now, this particular clock cycle is going to be get analyzed in this particular sequence, right? Here you see there is a particular cycle where actually there is a fall period. So during the falling period, the CPU is supposed to be in this idle. How long it will remain idle? Till the particular period is continuing. Then after time will come when the CPU again reach the peak time, right? So during the peak cycle, the CPU is supposed to be getting response over there, and during that response time, the CPU is going to receive the data from the resources, and accordingly the operations are going to be performed. Now, in contrast to your clock, if you analyze this bus, then during the burst, you see there is an address bus is there where actually the address is going to be get fetched throughout the particular process as long as the operation is going to be get performed, right? And of course, during the address performance over there, the data bus is used to pick the data or perform any data operation over there. And accordingly, the things is going to be get accomplished. Now, if I suppose to say that I want to perform the read operation over there, then the read operation will remain always on a high peak value where I supposed to say that yes, the values are going to be get acknowledged over there, right? Now, coming to the another sequence, if I supposed to say, so here you see there is a particular sequence called as a memory write operation. So during the read operation, as you have seen, like yes, the values are going to be get picked when you're supposed to have the data operation is to be get performed. So during the entire data operation, your read cycle will always remain in a high state, right? Means as long as the data is supposed to be get processed over there, the cycle is always remains in a high state, and accordingly the things is going to be get done, right? Now, in contrast to your read operation, if I supposed to say how my write operation is going to be get performed, say suppose. So during this write operation, you see the memory operation is going to be get performed. During the memory operation, see again in contrast to read, there is a very much similarities in terms of the write operation, but there is a little bit differences are there where actually the clock cycle is respond according to the different ways, right? So here you see the CPU places the address and the data on the first clock cycle because you are going to perform the write operation. So during the write operation, it is by default understood that yes, we are also going to perform the read operation in the meanwhile. Okay? The read operation is always going to be get performed in the simultaneous way, and according to this, only the entire process is going to be get accomplished. So at the start of the second clock cycle, okay, the CPU will assert the control signal over there. Then it will be get start the memory storing data over there, and then finally it is going to perform any sort of removal operation if it is required. Then accordingly the address and the another subsystem is supposed to be taken into consideration. Now, definitely you people will eagerly to know that what will be the timing cycle for this. So this is what the timing cycle is, right? So whenever I'm supposed to say about the timing cycle, this is the particular clock cycles are there where actually you see according to the clock cycle, the things are going to be get defined, right? Yeah. So in according to this particular thing, when the clock cycle is going to be taken into consideration, then address bus, the data bus is taken into the consideration, and the read operation is also going to be get performed according to that required, right? So I hope and I believe that yes, this part is clear so far. Or if you have any questions, then of course we are going to discuss at the end. But till then, this is the particular content that we're supposed to have, right? So whenever you're supposed to go for performing any read or write operation, any sort of things, of course, there are several things are also there that you must need to take it into your consideration, your accountability. Now, coming to the next, I'm just going to discuss about the read and write cycle, right? So far, we have seen that yes, how the instruction is taken into the consideration. We have already seen that yes, what are the timing constraints are there, like in terms of the read operation or in terms of the write operation, how the things is going to be get accomplished. So here, now next I'm going to discuss like what is an IO read and IO write cycle is, right? So naturally, whenever we're supposed to say about this IO read and IO write cycle, the first and most important thing comes over here is what exactly it is. So remember students here, actually this IO read is nothing but that is a particular read operation that defines some sort of input to be taken from the input unit to the system. So you may assume the constraints like you may say the resources like keyboard, that is one of the most important unit, fundamental unit through which you are supplying the data. Keyboard, after that you can have mouse, joysticks, webcam, all those particular things are nothing but input devices, right? Similarly, you are going to have the output devices also, like you have the video, you are going to have the printer, you are going to have the projectors. So there are several output devices are also there, where actually you are going to produce the processed outcome for the real-time scenario, right? Means for the real-time world, you are going to produce the outcome over there so that we can view the content over there and according to the particular thing is supposed to be understood. Now, when you're supposed to go for analyzing this particular IO read operation, and if you're supposed to perform any sort of write cycles over there, then naturally there are some sort of similarities in terms of your memory read and write operations are also going to be taken into the consideration. Right? So during this particular process, when we supposed to let it admire the things, there are certain prospects are there that you must need to have. Like the first thing is your memory mapping. Right? Whenever you're supposed to go for considering the memory mapping, there is a mapping is supposed to be done on the basis of some subsequences, right? Some subsequences are there. Okay, and based on that particular subsequences, the input and output system are going to be get implanted on the scenario, or it is used to perform some sort of things, right? Right. So now moving to the next, there is called as a processor. So here you can say that is the processor is used to perform some sort of fetch, which is an IO operation based on this particular location. For example, suppose you are going to perform any operation, so definitely at that particular time, you are going to fetch the data from the resources. So actually, when you're supposed to locate the resources, naturally the resources are going to be get located in terms of their addresses, right? So here, this particular thing is going to be get fetched in terms of your memory location, and according to the memory location itself, it is going to be taken into the consideration, right? Now, coming to the next, the result part. Of course, the result part is supposed to be get treated in terms of a memory access part. And here you are going to perform all the particular treatment as a particular memory accessibility only, right? Coming to the next and most important thing, that how they are working together over there. So if I supposed to analyze the overall aspect, so here this is the particular thing that I'm going to discuss, like program execution. So here the program execution is nothing but that is a particular stage, or that is a particular page where actually the PC is going to set the addresses where all the first program and instructions are going to be stored in the memory, right? And it is the particular process which is going to be get continued till we have not reached to the HUD. HUD is the end operation, or if in worst case you are not going to face any sort of fatal error, right? So until and unless the HUD is not reachable or the fatal operation is not reachable over there, we are going to face this particular issues, right? So fetching the instructions, decoding the instructions, execute the instructions, and end the loop. So these are the particular cycles are there where actually the whole particular process is supposed to be taken into considerations, right? Now, coming to the next, the same thing I'm just going to continue over there in terms of your page. So when you're supposed to go for the page, then here actually you see, you are also aware about the particular fact called as your MAR, which is called the memory address register. So first, the PC will assign the value to the MAR. Okay, here for the sake of convenience, I'm going to mention in terms of the written pattern over there, like put addresses in PC into your MAR, right? So here you are going to first provide the value of this PC to the MAR, where actually the MAR is solely responsible to access their addresses, and according to that addresses, only the things is going to be get uniquely identified in terms of the system. Now, then after we will go for the fetch operation in terms of your MDR. So here actually you are going to perform the signal memory to fetch values into your MDR, right? So fetching signal value is going to be done on the basis of your MDR only, right? And I hope if you are well remembered about this particular thing, like MDR and MDR are the special purpose registers over there, because these are the registers which is supposed to take part in terms of your executions perspective only, right? Then your MDR will assign the value to the IR, where actually move the value to instruction register, and then the PC is going to be updated. Now, at this particular stage, now I hope and I believe that yes, you are very much clear that how this PC is going to be updated over there, right? Now, if I supposed to say here, I am writing PC plus one is equal to PC, means what is the word size of my word over here? So it is of your 1 byte. If your word is about 4 byte, then definitely it will be around PC plus 4, right? That particular part we have already seen in the previous slide. And the same thing I'm just going to let it convey over here in terms of a 1 byte memory, right? Then comes to the decode page, right? So when you're supposed to go for the decode page, here the decode page will let you suggest that how particular IR is supposed to be get take part over there into the action. So instruction decode, that is the register part over there. So that decodes the instruction in the IR. And as you all know that yes, IR is the particular register which is used to hold the address of the current instruction which is there in the execution, right? So here the instruction decoder will generate the signals into the activate circuitry over there. And then after the things are going to be get processed and accomplishes over there in terms of its uses, right? Followed with the first and most important thing, that how the execution page is taken into the constitution. So here, this is little bit different in terms of your current scenario. For example, if I suppose to say now I want to perform the addition operation, means x plus y is equals to z if I want to perform. So here, if I suppose to go for the mnemonics form in the decoded order, then what I will do? So first you need to load x. Load is the operation which is let you allow to load the value of x into the corresponding register, which is also sometimes called as an accumulator, right? Then your IR will be get updated in terms of your MAR that we have already discussed in our previous slide. Then we will go for the fetching operation, and then finally the MDR will assign the value to the corresponding register. So this much of the operations are supposed to be get accomplished when we're supposed to go for performing the load operation. right? Coming to the add means now if I supposed to say that my content is loaded into my accumulator, now if I supposed to go for performing the operation, so who will going to perform the operation over there? The accumulator is going to be get operated over there. So here add x means what? Now this x is supposed to be get, taking the further left person exercise, and then it is supposed to go for performing the operations in terms of the phases. So here each phase of the instruction cycle can be decomposed into a subsequences of the elementary micro operations, which is nothing but each sequence is used to have a page indirect, execute and interrupt cycles, right? Now, if I'm supposed to say that if I want to let it summarize in terms of your diagram or any sort of things, then how do I able to do this? So here, this particular diagram is going to be get accomplishes in the sense like suppose here the cycle is supposed to be get showed in this particular way where actually you are going to have the page, execute, interrupt and indirect, right? So you see here now this particular page and execute is a bidirectional over here, followed with a cyclic structure where actually page defines the indirect operations, which follow in terms of your execute, then interrupt, and then finally goes to the fetch operation, right? So in defining this particular sequence, the things are going to be get taken part into your action. Okay. So I believe this particular part will help you a lot to let it understood that what exactly it is and how to do the things. Now, following to the next of this particular part, what are the key parts that you need to remember? Because that is the most crucial thing that you must need to know. Like these are certain instructions are written over here. Like in order to go for the better in terms of your understandability or understanding the things, here actually you need to understand this particular operations, right? So these are the operations that you must need to know. Now, coming to the advantage part, if I supposed to say, so of course, the standardization is a very important thing. So instruction cycle is used to provide a standard way to the CPU, where actually you are going to understand the overall aspect of the particular things and you are going to develop all the particular operations over there in a systematic process. This is the most important one in terms of your what advantages. Coming to the next, efficiency. Once you will go for this particular part, definitely your efficiency will be much better because here you are going to break down the instruction into the multiple steps. Means you are going to decode the instructions and then the CPU is going to execute the instructions step by step. Okay. And definitely when you're supposed to broken down the complexity level over here, so efficiency will be definitely going to get improved in a meanwhile. Followed with pipelining. Yes, of course, here we are going to use the pipelining concepts also where actually the pipelining is used to provide you have multiple instructions over there and different stages are also there that we will discuss in the later chapter, right? Yes, of course, there are some disadvantages are also there because if you're supposed to look at considering some advantages, there are some sort of disadvantages are also there, students. So first and biggest disadvantage is that overhead. Sometimes what happens when you're supposed to have some complex instruction in terms of your executions, then naturally the instruction has to go for the multiple stages over there, and due to because of this particular part, the CPU is completely going to get overload over there, right? That is the most biggest disadvantage. And if the CPU is going to get overloaded over there, then definitely the performance of the CPU will lag and the performance will decrease. Second is complexity. Yes, of course, if you're supposed to go for considering the complex instructions over there, then definitely the CPU architecture is also going to get enhanced over there, and that also bearing in terms of the cost expenditures, right? And limited parallelism. Like when you're supposed to go for considering the pipelining, and this pipelining, if you want to let it improve in terms of your performing the CPU performance point of view, then that is also limited because the performance can be limited in terms of the CPU architecture only, right? So here I have taken one example also like some instructions may depend on the results of the previous instructions, and likewise if you're supposed to have a complex instruction over there, then definitely the pipelining is also need to be improved over there, right? So at the meanwhile, now we are reaching to our conclusion part. So here, the most important thing I must need to say, like, yes, of course, there are several advantages and disadvantages are always be there. But when we supposed to consider this instruction cycle, then the instruction cycle is mainly depends on the CPU architecture and the instruction set that we are going to use. And according to this, only the distances architecture is supposed to be taken into the consideration, and that will be covered in the next presentation if possible. So this is all about the particular presentation, students, and I hope this particular presentation will definitely going to let you help to understand this particular stage of this particular instruction cycle in detail. And Yes, of course. If you're supposed to have any sort of further inputs over there, you can just put me in terms of your some response over there. We're happy to let you ensure, and accordingly we'll improve that particular part. And I will also going to present some more new topics on this particular record, which will definitely going to help you a lot in terms of your understanding the particular concept and grooming your concept in terms of your computer architecture and organizations. So, with the best wishes, friends, thank you. Thank you for your time and your wishes. Have a nice day. Thank you.